Hey everyone, welcome to Learn ReactJS for Frontend Development by CodeChef. So before we build real-world applications, let's look at how our JavaScript code runs. By default, JavaScript executes code line by line, but modern applications rely heavily on tasks like timers, API calls, and background operations. So in this video, we will be looking at asynchronous and synchronous JavaScript, and we'll understand why handling long-running tasks is critical for building a responsive application. So let's begin. So let us understand how JavaScript executes code. First, we'll see how synchronous JavaScript works, why it causes problems, and then move on to asynchronous JavaScript and its solutions. Synchronous JavaScript. By default, JavaScript runs synchronously. This means it executes code line by line, one step at a time. Each statement must finish before the next one starts. This behavior is simple, but it can cause issues when tasks take a long time. Now coming to the blocking problem. The main problem with synchronous execution is blocking. If one task takes too long, JavaScript cannot do anything else. The UI freezes, buttons stop responding, and the app feels broken. This is unacceptable for real-world applications. Now let us look at why we need asynchronous JavaScript. JavaScript is single-threaded, but applications still need to handle long tasks. Things like API calls, timers, and background work take time. Asynchronous JavaScript allows these tasks to run without blocking execution. This keeps applications responsive. So what does asynchronous JavaScript do? Instead of waiting, JavaScript starts a task and moves on. The task runs in the background. When it finishes, JavaScript handles the result. This is the core idea behind asynchronous execution. So let us look at callbacks now. The earliest way JavaScript handled asynchronous tasks was using callbacks. A callback is simply a function passed to another function. JavaScript calls this function later after the task is done. This works but becomes difficult to manage as code grows. So let's look at a callback example. First, JavaScript prints timer start. Then, setTimeout starts a timer and immediately moves on. JavaScript prints timer end without waiting. After 2 seconds, the callback runs and prints the final message. This shows how callbacks execute later. Now let us look at the callback hell example. Here, each asynchronous task depends on the previous one. To get comments, first we need posts. To get posts, first we need the user. This forces us to nest callbacks inside callbacks. As the logic grows, the code becomes hard to read and difficult to debug. Now let us see promises. Promises were introduced to solve callback-related problems. A promise represents a value that will be available in the future. Promises allow us to chain operations instead of nesting them. This makes code much cleaner. So let us see the states in promises. Every promise is always in one of these 3 states. Pending means it's still running. Fulfilled means it succeeded. Rejected means it failed. JavaScript manages these states automatically. Coming to an example for promises. In this code, the async operation starts and returns a promise. Each then method runs only after the previous step succeeds. If any step fails, the catch function handles the error. This avoids deep nesting and improves readability. Now let us look at what we use frequently in modern JavaScript. Async and await are built on top of promises. They allow us to write async code that looks synchronous. This makes the code easier to read and understand. Under the hood, it's still asynchronous. Now let us look at an example. Here, the async keyword allows us to use await. Await pauses the execution inside the function until the promise resolves. JavaScript does not block, it only waits logically. Errors are handled using try and catch. So why use async await in React? React applications constantly fetch data from APIs. Async and await make this logic simple and readable.
This is why async await is the standard approach in modern front-end development.
So now that we know what asynchronous JavaScript is, handling timers, background operations, and API calls become much easier. So to truly understand this concept, make sure to head over to the CodeChef platform and try out the practice problems yourself. So that was it for this lesson. I will see you in the next one. Thank you.